students. My name is Samson, aka Igwe. If today is your first day of coming across this channel, you can hit the subscription button and also the bell beside it for more updates and videos that will be coming. So today we'll be talking about endothermic and exothermic reaction, as well as their energy profile. And from the energy profile, we can also determine the activation energy and the enthalpy change for a particular reaction. So but we start with the definition of endothermic reaction or endothermic process. When we are talking about endothermic reaction, it is a reaction that involves the absorption of heat energy. Heat is being absorbed in an endothermic reaction. And whenever heat is absorbed, the internal energy of the system will change, because there will be increase in the internal energy of the system, which can lead to a change in state. The matter can change from one state to another state. In endothermic reaction, the enthalpy change, which is delta H, is positive. Examples of endothermic processes or reaction. One of it is boiling. When you supply heat to water, you discover that the water will absorb the heat and there will be change of state. It will move from liquid state to vapor phase. Then evaporation is also another example of endothermic reaction, because heat is being supplied. And again, melting of ice. If you have ice block and you supply heat to the ice, once the ice absorb the heat, they will change. There will be a change of state from solid state to liquid state. These are endothermic processes. But when we talk about chemical reactions that are endothermic, example is phosphorus pentachloride decomposing into phosphorus trichloride and chlorine, and nitrogen reacting with the oxygen to give us nitrous oxide. So in this case now, one of the ways you can know that a reaction is endothermic is by the delta H. If the delta H here is positive, that shows the reaction is endothermic. Again, delta H is positive. The enthalpy change must be positive, because the heat of the product is greater than the heat of the reactant in an endothermic reaction. That is why you have a positive sign. Then the next is exothermic reaction. When we are talking about exothermic reaction, it's a direct opposite of endo. Exo have to do with outside. Heat is given out, but endo have to do with inside. Heat is absorbed inside. So when we are talking about exothermic reaction, it's a reaction that involves the evolution of heat. Heat is given out. And examples of exothermic reaction is the following reaction. So these are the examples of exothermic reaction. In each of them, heat is involved. That is why the enthalpy change is negative. Heat is involved. Even the formation of water is an exothermic process, because the hydrogen combining with oxygen will lead to the evolution of heat. To balance the equation, we can have 2 here and 2 here. The equation is balanced. So the formation of ammonia using the Haber process is also an exothermic process, because heat is released when the product is formed. So we now be looking at the energy profile for each of these reactions, endothermic and exothermic reaction. Having defined them and given examples of each of them, so we look at their energy profile, and from the energy profile we can be able to determine the activation energy of the reaction.